Again, welcome to Java Programming Language. This is CS102 class. In these lectures, we're going to cover the Java expressions and arithmetic operators. This is Unit 2, Lecture Part 2, which cover Chapter 2 of our course textbook. So our main objective is to cover the Java expressions, data conventions, and also interactive programs. How this time we can write a program whereby we can ask the user to enter an input. The program will interact with the user. So first we start with the Java expression. And here we say that an expression is a combination of one or more operators and operands. Also, arithmetic expressions compute numeric results and make use of the arithmetic operators, same as a basic mathematics. So in Java, we have addition, which we use the plus sign, subtraction, multiplication, we use the asterisk sign, and division, and also remainder. A remainder is also called the modulus operator. It's when you divide two values, the remainder of it will give us the result. So for example, 7 modulus 3, the answer will be 7 divided by 3. The answer is 2, remainder 1. So 7 modulus 3, the answer will be 1. So we start with the division and the remainder, or the modulus operator. And here we say that if both operands to the division operator are integers, the result will be an integer. What we mean that if we are dividing two values and one of the value data type is a decimal or a floating point, then the result will be a decimal value. Now, if the two values are whole number, then the answer will be a whole number. So that's the example here. 14 divided by 3, the answer will be 4. We can see we're supposed to have some decimal or fraction part, but it's discarded. Same thing, 8 divided by 12, the answer should be 0 point something, at least 0.2 or so. But again, the decimal part is discarded. So when you are dividing two values and they are integers, your answer also will be an integer, a whole number. If one of them is a decimal, then, or both of them are decimal, then the answer will be decimal. Another example for the remainder operator, which also called the modulus operator, 14 modulus 3, the answer is 2. Why? Because 14 divided by 3, the answer will give us 4, but the remainder is 2. So the remainder is our result. Same thing, 8 modulus 12, the answer is 8. Why? Because 8 divided by 12, both numbers are integer, so the result will be integer. Or both numbers are whole numbers, so the result will be a whole number. So 8 divided by 12, the answer will be 0, remainder 8. So 8 modulus 12 will be 8. So let's take a look at some few examples here. 12 divided by 2 is 6. Why? Because both 12 and 2 are a whole number, so the answer also is a whole number. Now 12.0 divided by 2.0, the answer is 6.0, because 12.0 and 2.0 are decimal values. So the answer also will be decimal value. Now 10 divided by 4, the answer is 2, because 10 and 4, they are a whole number or an integer. So the answer will be an integer. The decimal part will be discarded. Now we have 10 divided by 4.0. This time we got the decimal part. So the answer will be 2.5. Because 4.0 is a decimal value. Anytime you divide two numbers, if both numbers are decimal value or one of them is a decimal value, then the answer will be a decimal value. If both of them are a whole number, then the answer will be a whole number. Next, we have 4 divided by 10. The answer is 0 because it's a whole number. But next, we have 4.0 divided by 10. The answer is 0.4. We have the decimal part. Now 12 modulus 3, the answer will be 0 because 12 divided by 3, the answer is 4, remainder 0. Same thing, 10 modulus 3, the answer will be 1 because 10 divided by 3, the answer is 3, remainder 1. And 3 modulus 10, the answer will be 0. Now, next we talk about the operator precedency. And the same as mathematics or college algebra, we have arithmetic operators, addition, subtraction, multiplication, division. Always multiplication, division will execute first before addition and subtraction. But first is parentheses. So parentheses always evaluate first, then the exponent, then multiplication, division from left to right, or addition, subtraction from left to right. So here we said operators can be combined into a larger expressions. Now, if I have an expressions with more than one arithmetic operators, then the order of precedence is very important. So here, let's assume these are our variables: total, count, mass, offset. They consist of values. So which operator will execute first will be division. After division, then from left to right, addition, subtraction. So here we see operators have a well-defined precedency, which determines the order in which they are evaluated. Multiplication, division, and remainder are evaluated before addition, subtraction, and string concatenation. Also, arithmetic operators with the same precedence, example will be multiplication, division, then they are evaluated from left to right. So if, for example, we have total divided by count, multiplied by mass, again, division will execute first from left, then next multiplication, because both of them are in the same order of precedency. So they will execute from left to right. But always, as we said, parentheses can be used to force the evaluation order. Always parentheses first. So if I have, let's say, parentheses total plus count divided by mass, I close the parentheses. We have total plus count, we close the open and close parentheses, then division is outside the parentheses divided by mass. This time, the plus will execute first before division. So always, again, parentheses first, and we shall see some few examples here. So let's look at this example. We have A plus B plus C plus D plus E. They are all the same order of precedence. So execution will start from left to right. So we have 1, 2, 3, 4. Now next we have A plus B times C minus D divided by E. Now multiplication and division are in the same order of precedence. So it will execute from left to right. So multiplication first, 1, then division 2, then addition and subtraction the same level. So from left to right. So addition first, then last will be the subtraction. So again, multiplication 1, division 2, addition 3, subtraction 4. Now here you can see that we have a parenthesis now, B plus C. We know that, again, division comes first before, or evaluate first before addition. But this time we have parentheses. As we said, parenthesis is always number 1. So this means B plus C will execute first before division. Then we talk about remainder. We know that division and modulus or remainder is the same order. So from left to right, then the last will be the subtraction. Now, if you have more than one parenthesis, then the inner parenthesis will execute first. So for example, here we have D minus U, D minus E will execute first because that is the inner parenthesis. Then next, the plus will execute because that is the next outer parenthesis. Then we have last small outer parenthesis, which will be multiplication. Here we have 3 parentheses. So the inner first, then the next plus, then the next multiplication. So after we finish with all the parentheses, then we do evaluate the division also. So this gives us again the whole idea of the order of precedence. Also, we can use something we call the expression trace to check if our expression is correct. So here we say the evaluation of a particular expression can be shown using an expression tree. So the operators the operators lower in the tree have the higher precedency for that expression. So we can see here parentheses have the higher precedency. So it's the lowest, B minus C. Then next will be the division before addition. So after B minus C, we have the result will be in the position of the minus. Then we have the result divided by D. Then the answer will be on the division. Then we add the two together. So we can see the root of the tree, which is the top, have the lower precedency, and the leaf of the tree, which is the lowest part, have the highest precedency. So we'll revisit assignment again. And we discuss about assignment operator. When we declare variables, we can assign values to it. And here also we say that assignment operator always has the lower precedency than even the arithmetic operators. So assignment operator. So for example, we have an expression here. You can see that here we are going to do division first, then multiplication, number 2, then we do addition. Then the result we are going to assign to answer variable. So here we say first the expression on the right-hand side of the assignment operator is evaluated. So that's why we say always the assignment operator have the lowest precedency. Now here also we have an assignment operator. Here we have count equal to count plus 1. You can see that we have a value in a variable named count. Now we add 1 to it and we give the result back to the same variable. So this is possible. We say first 1 is added to the original value of count, then we assign it to the same variable count. So again, the right and left hand side of an assignment statement can contain the same variable. So here we have the count and count again. What this means again is that we had one value, which is 1, to the original value of count, then we assign it back to the same count. So if, for example, the original value of count is 6, then it will be 7 because 6 plus 1 is 7. Then we assign it to the same variable. And also we have something we call the increment and decrement operator in Java. Normally the increment operator is double plus sign, so plus plus. Then the decrement operator is minus minus. So what this operators does is that they reduce a value by 1 or increase the value by 1. Increment will increase the value by 1 and decrement will decrease the value by 1. So previously we have an example saying count equal to count plus 1. Since I'm adding 1 to it, I can just write count plus plus. So if count is 5, count plus plus will be 6. Same here, if count is 5, 5 plus 1 will be 6. So here we have two types. The increment and decrement operators can be applied as a postphase form or prephase form. Normally, if we have the expression, a very simple expression, count plus plus or plus plus count, they're almost the same. But if you have a very large expression, there can be difference. Now, the difference between post form and postphase form and a prephase form is that count plus plus means, postphase means I will use count to do something. When I finish, then I'll increment it by 1. With the prephase form is I will increment my count by 1, then I use it. So that's why it's prephase. Increment first before you use it. Postphase, use it first. When you finish, you increment it. But as we said, when we have a very large expression, then this difference will come. But if we just wrote count plus plus or plus plus count by itself, then there's not much difference. So often we perform an operation on a variable, then we store the result back into that variable. And we saw that count equal to count plus 1. Now there's a way we can write this. For example, I have num equal to num plus 1. Now, since I'm going to add a value to a num, which is inside the count, then I will give that variable back to num. We can write it in this form, num plus equal count. Num plus equal count means I'm going to add count to num, and I will assign the result back to num again. So we call this sometimes a shorthand. Num equal to num plus count. The short is num plus equal count. And we have few examples for odd operators. For example, plus equal. If I said x plus equal y, it means s equal to s plus y. If I said x minus equal y, it means s equal to s minus y. If I said x multiply equal y, means s equal to s multiplied by y. Also, if I said x divided equal y, it means s equal to x divided by y. Also, if I said s modulus equal y, it means s equal to s modulus y. So we said the right-hand side of an assignment operator can be the complex expression, as we see this example here. So this example here means result equal to result divided by total minus mean modulus num. So we do our result finish, we assign it to the result. So same as equivalent here. So we say again, the right-hand side of an assignment operator can be the complex expression. Then the entire right-hand expression is evaluated first. Then the result is combined with the original value. So result equal to result divided by total minus mean modulus num is the same as saying, since we have the same variable, we are assigning the result to the same variable. We can also write result divided equal total minus mean modulus num, which means result equal to result divided by total minus mean modulus num. Now, the behavior of some of the assignment operators depends again on the types of the operands we are using. So for example, if the operands to the plus equal operator are strings, then the assignment operator performs string concatenation. Remember, we said that string concatenation is the plus sign. So if I have two values, the operands are two values, the plus will act as addition. But if one of these two operands are string or both of them are string, then the plus sign will act as a concatenation operator, which means it will join the the operands together, not to add them. So next, let's go to the data convention. The concept of data convention is changing a data type, let's say decimal, to a whole number, or from a whole number to decimal, etc. So here we say sometimes it's very convenient to convert data from one type to another. For example, in a particular situation, we may want to treat an integer as a floating point value. Now, these conversions do not change the type of variable or the value that is stored in it. They only convert a value as part of a computation. And so we have two types of conventions. The widening convention. Widening convention is very safe, which means we are converting. We know that a data type always have a size, the limit of the size it can have. So here, if we are converting one data type to another, and the one we are converting to is very small or very large, then we may have either widening or narrowing. Now, widening means it's very, here we say safest because we don't lose any data. For example, we know the data type short is a very small value comparing to int. Both of them are whole numbers. But since short is smaller value than int, if I do this conversion from short to int, I will never lose any value because int can carry more larger value than short. Now, if I do the opposite, then we call it narrow. So narrow conversion, we can lose information because they tend to convert larger data type to smaller one. So I'm converting int to a short, which means int can be a very large value where short cannot store it. So in this case, we can lose data. So in Java, a data conversion can occur in three ways. First, we do the assignment conversion. Then the second, promotion. Promotion is done by the system. And also casting, we can do it ourselves. So casting means we convert the data ourselves. Promotion, again, is implicit. Casting is explicit. So example of a widening convention, as we say, widening convention means we are changing small data type to larger. So we can see byte is smaller than short, int, long, float, and double. Narrowing, we can go opposite. We know character is bigger than byte and character. So short, we convert to int, long, float, or double. Here we don't have no more byte because byte is smaller than short is greater than byte. Then char, we can convert int, long, float, or double because they are greater. Int, long, float, or double, they are greater than int, etc. So first we go to the assignment convention. We see assignment convention occurs when a value of one type is assigned to a variable of another. So for example, here we have int dollars equal to 20. So we assign 20 to dollars. Then we assign dollars to money, but money is double. So we do assignment convention. And in this case, we know that double should be greater than int. So in assignment convention, we say only widening convention can happen through assignment. We should know that the value or type of dollars do not change. The value in the dollars variable, again, do not change. But since double is greater than int, we can use assignment. The opposite will not work. Now, promotion happen automatically, so we said implicitly. Promotions happens automatically when operators in expression convert their operands. So example, we have a variable named count, we assign 12 to it, and it's int. Then we have a variable named sum, is double, we assign a value to it, 490.27, which is double. Now we say result equal to sum divided by count. Remember we said if we are dividing two items and one of them is a float or both of them are float, then the result will be a float. So automatically 12 will change. So here we say the value of count is converted to floating point. Because count is int, but it will be converted to floating to perform the division calculations. Now, casting is the most powerful and dangerous technique for convention because we can use it for both widening and narrow. Remember, we said assignment we can only use for widening convention, so it's very good. We don't lose no data. But casting, since we can also use it for narrow conversion, which means I'm converting a larger data type to a smaller data type, there's a chance that I may lose data or I may lose value. So to cast, the type is put on the parentheses in front of the value be converted. So nice example here. We can say our total variable is int, but we want to cast it to float. So we just put the float in parentheses in front of the total. So in this case, total now is a float data type, not int. Then we divide by 6. So our result will be a floating point result. So without a cast, the fractional part of the answer will be lost. Since total is int and 6 is int, if I say result equal to total divided by 6, then we are going to get an int value result. So we cast it. Same thing, you can cast with int, char, any data type, put it in a parenthesis, then the next will be the variable name. So next we're going to cover the interactive programs. We say programs generally need an input on which to operate. In our previous lectures, we saw some few Java program examples, but most of the time we don't ask the user for an input. We declare variable, then we use the assignment operator to assign value. This time we can use what we call the scanner class. In order to use the scanner class, we need to import a package called utility package, java.util. So here we say programs generally need input on which to operate. The scanner class provide a convenient method for reading input values of various types. Also, a scanner object can be set up to read input from various sources, including the user typing values on the keyboard. Now, if you are using keyboard, then we use system.in. So keyboard input is represented by system.in object. And that's what we are going to learn in this section. So reading input, we say the foreign line create a scanner object that read from a keyboard. So here we have what the scan variable here is called a scan object. So first we create a scan object, always that's a step. Scanner, the class name, scan the object equal to new scan system.in. System.in here means we are going to use the keyboard to get an input. We can also use the scanner class to get input from a file system, which we are going to discuss later by the end of the class, getting to the end of the class section. So the new operator creates the scanner object. In object-oriented programming, we are going to discuss what new means. But again, the new operator always creates an. Anytime we are going to create an object from a class, we use new operator. So the new operator creates the scanner object. The name can be any name, the scanner object. Here we name it scan. You can name it input. You can name it any name you want to. It's good to have a meaningful name such as input or console scan. Now, once created, now we can use the scanner object to invoke the input method. In this case, since our data type is a string, we use the scan object scan.nextLine. Then user enter the input into a variable named answer. So always when we use the the input method, we always have to assign it to a variable, because when we get an input to a program, we need to store it somewhere. A variable is a storage location. And also we can use nextInt. NextInt, int we start with the capital letter INT with the open close parentheses. It means we are going to enter a whole number. We have next double fraction. So it depends on the data type. You will know what input method to use. So the scanner class, again, is part of the java.util class, as we said. So we need to import it into our program. And then the next line method also read all of the input until the end of the line. So we shall see example echo.java. Also, we'll see detail of object creation and class library, which we are going to discuss in our course textbook chapter 3, and that will be the next lectures. So let's see the echo.java. So you can see the first thing we do, we import the package. Now in Java, if you want to import a package, you start with the keyword import. Then the package name. Here the package name is util. So java.util.scanner. I'm importing all the scanner. Now if I want to import all the classes in utility package or util package, I will say import space java.util.asterisk. I will use the asterisk and that will import everything, then semicolon. You always have to end the expression with semicolon. So here we are going to import only the scanner class. So we have import java.util.scanner. Then we have our main class. As we always say, Java, we need a main class. And the main class name is the same as the file name. So the file name is echo.java. This is a very small program. We have our main method. We declare variable name message. The data type is string. So this is the reason why we use the next line. Now, if the data type is int and we need a value, we are going to use next int. So now we have our variable where we are going to store the user input. The next we create our scanner object. We name it scan. Using scanner, scan equal to new scanner system.in. System.in, as we said, tell us that the input will come from a keyboard. The keyword new and the syntax here means we are creating an object named scan. Now, next we ask the user, enter a line of text. That's the instruction. When we execute this program, that's the first instruction we will see. Then we see the cursor is blinking. Then we enter our new line. So maybe John is whatever you want to enter. When we enter finish, we want to print it. So here we say system.out.println. You enter, we have a quotation. So since we want to print a quotation, the escape sequence, we start with the backslash, then two quotations. Then we have quotation and backslash again too. So we are going to print a quotation on the input that we enter, double quotes, beginning, end. So let's see the output. You can see when we run the program, the first system.out.println said, enter a line of text. We are using println, so the cursor will move to the next line. So the user enter, you want flies with that. And so that's what the user enter. Then we print system.out. We start with the double quotation, as we said, and we print the content of the message which the user enter. You want fries with that, and then the double quotation again. Now in Java, we have something called the input tokens. Again, unless specified otherwise, white space is used to separate elements, which is called tokens of the input. So white space include space characters, your tab, new line characters, etc. Now the next method of the scanner class read the next input token and return it as a string. Now methods such as next int and next double will read data of particular type. So let's see an example here. Again, we have a program here that's going to use a scanner class. So first thing we do, we import the scanner class, import java.util.scanner. Our main class name is gas marriage. So the file name again is gasmarriage.java. And we have our main method. This program will calculate the fuel efficiency based on values entered by the user. So we declare our first variable type is int, miles. Then we declare two more variables, gallons, mpg. Their type is double. We create our scanner object because we want to get the input from the user. Now we tell the user, enter the number of miles. This time the number of miles is a value, maybe 5 miles, 10 miles. So we use the input method is next int, a whole number. So the scanner object scan.nextInt. User will enter any value. If user enter a wrong, for example, user enter string, let's say John, we get an error because miles, the data type is int. And also we are using nextInt method. So after the user enter the miles, here we say enter the gallons of fuel use. So remember the gallons and the data type for gallons is double. So now we are using the method next double, input method next double with the scanner object scan.next double. So now we have our two inputs. So to calculate the miles per gallon is equal to miles divided by gallons. Then we print our result, system.out.println. Miles per gallon is whatever value we will get based on the input we have for miles and gallon. So what we are learning here is that how to use the scanner class. This time our input can be int or double. So next int, next double. We also use the next line, which means strings. So when we run this program, they say we should enter the number of miles, we say 328. Enter the gallons of fuel use. Remember, gallons, the data type is double, so we have enter 11.2. Now 328 divided by 11.2, the answer will be 29.28571, etc. So that will be the conclusion of our lectures. Again, so in these lectures, again, we went through Java expressions, most important arithmetic operators, and also how we can write a Java program whereby we can interact with the program, allow the user to enter an input using the scanner class. So again, wish everybody the best and thank you very much.